Assalamualaikum and good day. Today, I would like to explain about lecture 6. So, lecture 6 is continuing from lecture 5. In the lecture 5, we are already talking about muffler. So, as we know, the muffler is the divided by two types. Yeah. So, now we try to continue from that case on the noising, yeah, how to measuring noising, and then the tolerance of the noising itself, yeah, how we can use the standard in the certain building, and then how to we can acceptable that noise, so the range will be listed, yeah, by the standard. So today, uh, as mentioned in the slide, yeah, you can see the first one we try to identify instrumentation for noise measurement, and then the second identify type of frequency analysis in sound meter. So the last explain function of dBA. Yeah, this one is unit of the noise, yeah, range. So from that, you can understand in the last final of the lecture class, yeah, for the all of the objectives, yeah, you can come out with this, yeah, objective. So noise. So in the introduction, yeah, shown in the slide, so you should be understand first the definition, yeah, the noise itself, yeah. So what is the noise, yeah? You should be understand before we eliminate, yeah, the noise from the building or in the anything, yeah, maybe in a residency or in the office system, yeah. So the first, unwanted noise makes a workplace uncomfortable and less productive. Yeah. So in the definition for the noise, how we consider this noise. Once, yeah, this one is considered uncomfortable and less, yeah, productive. Yeah, if we refer to the uh, workplace, yeah, so mean that something we don't want, yeah, disturb us during uh, working day. Yeah. And the second, when people are surveyed about workplace comfort, the their most prevalent complaints involve the heating, ventilating, and air conditioning or HVAC system. So one another thing, yeah, from the uncomfortable consideration, yeah. So it's not really relate to the maybe a noise system, but this one is relate from the maybe from the comfortable in uh, air conditioning system. So actually, air conditioning system also can create a noise, and then is considered also uncomfortable. Maybe we can realize this uh, happen, yeah, in the our building in the F3, yeah. So some maybe can create the very noisy. So actually, uh, uh, once considered uncomfortable, yeah, and then effect to less productivity in the amount around the staff. So maybe this one also consider as noise, yeah. So the last one, in our definition, the problem they cite most frequently, aside from temperature control, have to do with excessive noise and vibration. Yeah. So actually, as we know also, in the beginning, actually, noise also can convert, yeah, into the heat, yeah, and then also make like uncomfortable in the air conditioning system. Yeah. Okay, move to second slide. Yeah, talking about noise measurement. Okay, before we consider this one is as uncomfortable. before that, the engineers should be informed or collect the data and inform the owner of the building, how much, yeah, we can provide the noise in the building due to the HVAC activity. Yeah. So that's one we need to the some uh, measurement, yeah, to collect data. So we go to the slide, back to the slide. There are many reasons to make noise measurement, noise data, content, amplitude, frequency, time, or phase information, which allows us to, the first one, identify and locate dominant noise source. So we can find where is the noise come from, and then we can measure and optimize selection of noise control device, method, material. So before we get collect the data, and then we can collect the source, yeah, how much source can be uh, what contribute, yeah, for the noise system in the building. Evaluate and compare noise control measures, determine compliance with noise criteria and regulations, and quantify the strength or power of the sound source, determine the acoustic qualities of a room and its suitability for various uses, and many, many more. So actually, we already learned about how to we collect some of source sound, yeah. So then we can collect and calculate, yeah, how much can produce in the maybe, if not by mistaken, yeah, on that lecture 3, yeah, we already learned how to calculate or sum the noise, and then we can calculate, yeah, the sum of noise, and then consider how much, and then after noise, after measuring of noisement, performance characteristic, the frequency response range of frequency over which an instrument produces the correct amplitude of the variable being measured within the acceptable limit. Yeah. So after we collect data and then sum the sum of source of the noise, yeah, and then we can compare to the standard, and then actually the standard already listed by table, and then we can check if this one category of which building, and then we can refer the table, and then which is the in the still in the ring or not. Yeah. So typically limit of a specified frequency range. Yeah. Okay, microphone is to dB. Yeah, plus minus, yeah, into dB, and tape recorder 1 or 3 dB. That's for our reference. Yeah, or to measure. Is it consider how much, in the dB? So we can refer. Yeah, if microphone, we can identify is not mass maybe 2 dB and so on, yeah. And loudspeaker is 5 dB, yeah, for the noise source. Performance characteristic, yeah, still in for performance characteristic, the dynamic range amplitude ratio between the maximum input level and instrument internal noise floor or self noise or measurement should be at the least 10 dB greater than the noise floor. The typically dynamic range of meter is 60 dB, more is better. So this one is already mentioned, guide us. Consider in the should be not more than that, yeah, to design something, yeah, in the noising of the building, yeah. Response time, the time interval required for an instrument to respond to a full scale input, limited typically by output device like meters, plotters, yeah. Okay, this one is one of our instrument to measurement activities. Yeah, sound measurement, sound level meter. So maybe after we construct the HVAC system or building already done, and then we go for last, yeah, uh, last activities, yeah, before we hand over to the owner of building, and then we collect the data for the sound measurement. Yeah. So sound is measured in the decibel with the use of the sound level meter. So This one is one of example of sound measurement. Yeah? And the sound level meter respond to sound in the approximately the same way as the human ear, but it give an objective measurement of sound level. So this one is received by similar like the human ear, but in the using the meter reading in meter. So in the screen we can capture the level of dB, yeah, because the sound level meter using the dB, yeah, disable, and the sound to be measured is converted into an electrical signal by a microphone. Yeah. Normally, condenser microphone are used for the precision grade instrument. So this one is for accurate, yeah, number. So every because we engineer should be report in the number. Anything will be number. So how much? If low, how much? And then if medium, how much? And then if high, consider high is what number. So anything will be report by number because we are engineer. So should be report by number. Since the signal is quite small, it's necessary to amplify it and then convert to display on the meter. So anything is convert to number. Yeah. Sound measurement, sound level meter. So mentioned here the level within comparison. Yeah, within the decibel dB within the frequency. Yeah, so we can compare here. When measuring the sound level from the source, the meter should be held at a distance of 1 meter from the source. Yeah. Okay, this one is a procedure how to the measurement activities procedure. The sound level in decibel A scale can be measured at each center frequency using the filter, and graph can then be drawn by the example as shown below. Yeah. So actually we plot based on the condition, sometimes by distance, and then from the source. Yeah, then we can mapping the sound traveling, and then by that we can measure by the uh, document, and then we mapping, and then we can understand how much, yeah, the sound traveling, and then how far, and then what we can prevention before traveling the sound traveling into the certain area. So we can maybe block, yeah, or before that we have already in the muffler to prevent the sound traveling uh, much, yeah, or far. So better we prevent the first time by the muffler system, and then before that, after that we can block, yeah, by the maybe by the room, and then the wall, and then the wall maybe already absorb the sound, and then we can close area, and then maybe we can reduce much, yeah, of the pollution of the noise. Yeah, they give us an indication of sound level at the different frequency. Yeah, so okay, we back to the graph. Yeah, so mean that the decibel will be mentioned the frequency. Yeah, this can be used information and can be used to design appropriate attenuation and acoustic treatment at particular frequency. Okay, if we already mapping the frequency inside the building, and then we know by the frequency we know how to prevent the frequency. Yeah? So as we know, the muffler or the material will be absorbed much of frequency. So that's why we need to mapping the area by the frequency also, and then we now understand by characteristic of the material, and then we understand how much frequency can be absorbed and transmitted. Yeah. Okay, this one is a example you can see by yourself. So because of we still in the Incrosinas, so I don't want to uh, expand this presentation by show the video, so better you can see by yourself, yeah, this link to understand the video message, yeah. Okay, this one is one of type of the measurement, yeah, noise measurement. Yeah, you can see we have the microphone. Microphone will be capture the frequency and then convert into the reading. Yeah, so we can see the screen showing by the dB, yeah, decibel. Okay, noise dosimeter combines sound pressure and time for employee exposure monitoring. And the second bullet, this small microphone can be worn at the ear, on a collar or on the shoulder. So mean that the equipment is very high mobility, and then we just put the in pocket and then will be read, and then the microphone will be put nearest to our ear, so the same thing effect like our ear, so we can hear around the ear, so like this, so same thing, so will be put on the nearest to our ear. The purpose is to get the noise exposed, yeah, to the working during working in their working place. So same thing, yeah, like the ear function. So now we go to other measurement. Yeah, we call the octave band analyzer. Real-time analyzer or octave band analyzer are special sound level meter that divide noise into its frequency component. Electronic filter circuit are used to divide the sound or noise into the individual frequency band. So, mentioned from the previous class, I actually explained about the octave. Yeah? So we have several octave, maybe eight octave frequency. In then slide explain eight octave we have. So each octave they have a frequency range. Yeah. So if more than higher this range, so we call what which octave. Yeah. So we can consider from the that measurement. So the measurement will be tell us about the octave. So octave mean that the frequency range. Yeah? Real-time analyzer or octave band analyzer are special sound level meter. Yeah? And then the electronic circuit are used to divide the sound or noise into individual frequency band. So they convert into frequency, individual frequency. Yeah? Most octave band filter set provide filter with the following center frequency. So they have a setting, of frequency. So this range of setting of frequency they can capture. So we have several range. So which range actually, and then they make individual or single frequency, to come up with the reading. For more detailed analysis, the spectrum is sometimes measured in one-third octave band. So sometimes we can capture by one-third of the octave. So within the octave, within that one octave, so we can separate by three. Octave band analyzer, real-time analyzer, or octave band analyzer are used to help determine the adequacy of various types of the frequency dependent noise control. Selected hearing protector because they can measure the amount of the attenuation, how much a sound is weakened offered by the protector in selected octave band. Yeah. Analyze the frequency content of noise. So actually, once we can capture the frequency range, and then we know the how to prevent that frequency. So actually this must help the engineer to capture the frequency, because we know the material, what type material we can use, and what type of muffler or absorber of the noise, to block the noise, and then we can play that range only. Then this measurement is much help the engineer to determine what type of the absorber. Now, sound measurement, sound level meter. Sound level meter are programmed to account for the human ear sensitivity to certain frequency. So actually, once we capture the frequency, so we can understand this range is cannot acceptable by the human. So maybe we can do prevention. Yeah. The meter measures the sound pressure in all the different frequencies, correct them for the human ears, and presents us with a single figure representation of noise. So we try to capture some maybe variety of frequency, and then we can play with the come out with the one single frequency to prevent. So once we prevent, and then uh, maybe we can reduce much of frequency, then we can make a single come out from the absorber, single frequency. So that frequency actually we can control to make the comfortable to human. Yeah. A weighted measurement disable that combine octave band sound data into a single number descriptor. So the latter indicate that the sound has been filtered to reduce the strength of very low and very high frequency sound, much as the human ear does. Yeah. So as mentioned, this one. Okay, what I mentioned in beginning of lecture class, and then we try to make a range of condition in certain area. So that's why we need to refer the standard that allow us which string actually acceptable or tolerate to human. Yeah. So as mentioned in the slide, a weighted sound level in decibel, and then weighted 120 over a level uncomfortable loud. So this mean the 120 is not comfortable. Noise environment, military jet airplane take off, blah blah blah. So 120 at least come the noise source is come from military jet airplane take off at 50 feet. So you can imagine how noise is 120. The main advantages with the awakening are as follow. It's adapted to the response of the human ear to the sound, and the second is possible to measure easily with low cost instrument. Okay, refer to table. Yeah, they have several range of the decibel from the 0, 10 until to 100. Yeah, as maximal. So you can identify which noise is come from if 180 and 70 and so on. Yeah. So we can allow the sound maybe is from the 60 below of dB decibel. Yeah. After that, maybe we can cannot acceptable uh, even in the 70 moderate loud is still make noise, noisy. Yeah, I think. So we cannot work in this area. 70 cannot work. Yeah. And then maybe 60 still consider quiet, but still have uncomfortable some person. Yeah. So they have problem with this 60. Yeah. Like the maybe autism people can accept the 60 decibel. Weighted level decibel A, most of the noise are measured in the weighted sound level in dBA. A mean weighted. Weighted is an electronic frequency weighting network single number rating system that indicated reading of different frequency based on the human response in the sound level meter it will show graph that will be related to the loudness of the noise. Yeah. So mean that definition of the vector level. Okay, this one is describe, yeah, about the ecological contour. Yeah. This one. So 10, 20 until to 130 decibel sound. This one is from the source, yeah, from the source. So this one the frequency, and then frequency maintenance, yeah. Uh, frequency maintaining network was first introduced in the 1950s. Yeah. So this one is also mapping. Yeah, BND is a weighting network. So mentioned already by graph. Yeah. So weighting by frequency, sound, and then the BD weighting network are no longer DB. In the sea, weighting some is used for noise from gun and explosion. Yeah. This one example reading or waiting. This example after measurement, relative response decibel from the frequency. So this one the mention, yeah. One the mention the frequency is some is related to the dB, yeah. And then after that, so the curve is a peak and then come down by the frequency and by the respond dB. Okay, next, weighting network. Not that the C weighting doesn't wake to the low frequency as much as the weighting. The difference between the A and C level is sometimes used to quantify the low frequency content the sound. So totally relate to the what difference within the A and B and C is based on the frequency. Some frequency sound increasing, but the some once frequency mean that the frequency increase, but sometimes the noise we cannot hear anymore. So will be shown in the low of dB. Okay, that's all for today for the lecture 6. So I hope you can fulfill the quiz for your attendance. Yeah? After the finish the class, please go to the quiz and answer the question, and then please answer all the question for your attendance. Thank you. That's all for today. Assalamualaikum and good day.